Hi, my name is Emmanuel, and today it's my pleasure to introduce you to the Planthub monitoring system. It's a system that is supposed to keep the plant alive in a cold basement. We'll be going over the subsystems involved in this. So let's get right into it. First, we're going to examine our microcontroller. For this application, I decided to go with the Arduino Nano. It extrapolates data from our soil moisture sensor, our BME 280 temperature, humidity, and pressure sensor right there. But for this application, we only decided to go with the temperature and humidity. Next, we're going to examine our voltage regulator and the capacitors that are used to power the circuit. First capacitor over here is our 330 microfarad capacitor, and the second one is our 100 microfarad capacitor, and this is our 1000 microfarad capacitor that is in pair with the switch, which cuts power to the entire PCB. Now, back to the voltage regulator. It takes 12 volts from the power adapter, 12 volts and 2 amps precisely, and converts it to 1.5 amps and 5 volts that powers everything on the circuit, including the Arduino, except for the LED and the water pump, which are both 12 volt devices. Now, speaking of the 12 volt devices, to control them, we decided to use MOSFETs, 4 precisely. Now, we used 3 over here to control the red, blue, and green light and the light strips. Fortunately, the blue light burnt out, so for future applications, we'll decide to go with more complex LED lights, or to be more precise, more expensive ones, since these ones were cheap and burnt out on us. Next is also our 12 volt water pump, which also blew out on us because it was the cheapest water pump I could find. For future applications, we'll definitely be picking more efficient water pumps that are not the cheapest. Now, going back to the board, if you see, you can notice that there are 3 headers over here that are missing components, 1, 2, and 3. We're going to explain what those are, and we're going to explain why we omitted them. Firstly, that is the Bluetooth module header. It was supposed to house the HM10, but it was not receiving data, so we decided to scrap the idea of adding it to this for now. We're going to go with the HC05 for future implementations. A lot more easy to use, and we've had prior experience with it. Next, we have our header that is supposed to house a light intensity sensory module. For this project, it was deemed too simple to use a light intensity. We did not need it, so we decided not to add it. But for future applications, it will definitely be on the list. Next, last, but not the least, is our sonar sensor header right here. That is supposed to house the sonar sensor, which was supposed to measure the water level in our water container. But it was eventually deemed too dangerous and health risk, so we decided to omit it. But if we can definitely find an application for it in the future, expanse of this, it'll definitely be added in. Now, we're going to examine how we were able to send information from our Arduino to control the LED lights and 12 volt water pump. We used our 10K current limiting resistors over here, again, the MOSFETs, to control them. Now, we're going to show the case at the outside, and we're going to take a look at the user interface. For this, we chose a 20x4 LCD display screen that was mounted in front of the case. It displays the date, the time, the temperature, Celsius, and the humidity, and also the soil moisture sensor. For future applications, we're definitely going to tweak the code a little bit so it's more static, less shaky, and overall better experience to use. Overall, this project was a success, but there are definitely some problems that occurred from choosing cheap components, and that mistake will definitely not be made in the future. Thank you very much for tuning in. Emmanuel signing off.